Hi, my name's Andrew McLaren, and today I want to talk to you about how to look at physics problems intuitively or with a line of equivalencies. So you've got all these little parts that add up to some whole. So oftentimes there's like some number, like maybe three different numbers that you're adding up, and you're comparing that to like four different numbers. Now this all has to be of the same quantity. So this could be like for forces, or this could be for energy. So you're looking at different pieces of energy and summing them all up at like different scenarios. There's tons of different situations where you will have this format, but you want to keep it in what I'm going to call this line format. And a lot of physics teachers will have you do things where they want you to like rearrange or substitute parts in to formulas, but then it gets kind of confusing because like I like this with the sum of forces written as is besides the minus mg here. To me, that there's negative acceleration from gravity that accounts for the negativeness. I never subtract forces. And that's one of the main issues where if you take this line format and rearrange, this negative piece with gravity oftentimes gets confused with subtraction, and then you think you're adding numbers where you're really adding a negative number. And so it can get conceptually very difficult to follow. And you can see that this professor really likes to do substitutions like to like a crazy degree. And I want to move away from that because when you do too many substitutions, you don't know what you're doing or how you're doing it. You can kind of see in this problem, they had the energies where they looked at the energies here in purple, and that was okay. That this looks okay to me where they're like, okay, you've got these different energies that add up to these other energies. And I would just solve for those energy values and then work with those and relate them. Instead, this teacher wants crazy amounts of substitutions where you're rearranging for one variable. Now you can do that, but it's a lot harder to follow. So I've got a ton of examples here to show you this. Here's an energy example where there's someone on some skis going down a mountain. We need to know how fast they're going at the bottom of the mountain. The intuitive way to do this is if you have all of the energies and you just account for those numbers, energy should be a positive value. So if you think about it in that regard, you are kind of subtracting some numbers, but that's because the energy was being brought from one side to another side to account for the unknown. And if you keep it arranged like this with them all in that line format, you can plug the numbers back in and you can see like in this problem, I was solving for this thermal energy. I called that TE, sometimes it's called Q, but I had a question mark there and I solved for the other numbers that I did know. Like I knew at the beginning they had some sort of gravitational energy that turned into kinetic energy, and there's also some thermal energy that's being created due to that friction. And so we know at the end there they have no height, so there's no more gravitational potential energy. Should all be kinetic with some thermal. And in this problem, it looks like a lot of the energy turns into thermal energy. So they're skiing down something with quite a bit of friction here. So they're not going very fast to the end, which is kind of like counterintuitive given the problem. So you want to check your understanding as well to make sure what you're doing makes sense. But you can kind of see how the numbers relate here, where it's like, oh yeah, if they were going a certain speed, that's a lot slower than what you might expect. And so there was quite a bit of thermal energy that was created here. So that to me is a lot more intuitive and I'm able to follow that if I keep it in that line format. The key that I had for that problem was pretty awful. Let me see if I can find 53. Just give me 2 seconds. So you can see how the professor wrote the key here out, and it's very confusing. But basically, in this thing, you're seeing that there's a kinetic energy and you're subtracting potential energy from that, but it's like a negative kinetic energy that you're subtracting potential energy from. And it's like, wait, what? Why? How are these related in this way? What's going on here? And it's a little bit confusing. It's a lot easier to see these things if you look at the initial energy and the final energy and sum up the numbers, as you can see, versus trying to find the relationship, find the value for every single sub thing, plug it into like a massive formula, then relate it. That's just really tricky to do. And for those of you who are kind of earlier on in the year. Sorry about that. I cut this problem from some other slides and some numbers did not transfer over. Basically, this is a more typical problem that I would go over in the first session with a lot of students, where you have a sum of forces and a couple different forces, and you need to keep track of their signs and how they're being combined. And that is so much more intuitive if you do it in this line format than rearranging. You can see that this is how that teacher's suggesting they do this problem 19. It is very difficult to follow when you write out all this stuff with all of it substituted in. I would prefer to just keep it in this format and get value to numbers and see how they relate. Now, it is also useful having it in this format because you can switch the positive negative direction, and that's okay. So for example, in this problem, it just makes more sense to turn the gravity into a positive value because the acceleration is going downwards, which we could also be a positive value. And then the force normal is a negative value. So this is what I'm calling the flipped perspective, because typically up is positive. So you can have this relationship, and then you can be like, okay, let's try and find some numbers and plug those in. But if you're not looking at this intuitively, you're going to mess up these signs. You can easily imagine someone thinking that the sum of forces is negative and working with a positive gravity value, and then they get a wrong force normal. And so you can, with this problem, if you plug in your acceleration of gravity and the mass, you can see like, oh, there's a positive, say about 9,000 or 10,000 newtons going down. And then you've got this sum of forces, which you can actually solve for that using the mass and the velocity and the radius that they've given you. And so you can see like, oh, well, that's about 3,000 to 4,000 newtons. But that's going in the same like direction as the force gravity. So if you want to relate these, you could either have this be a negative and this be a negative and this number be positive, which is kind of like that typical format. Or you can work with this being positive, and now this should be a negative value. Like the force normal should be a opposite direction than the force of gravity, and the sum of forces is pointing down as well. So we want to be keeping that in mind. So you can see that I've kind of written in the sum of forces is down, which is positive here. And you can only really see that if you've left it in this simple formula and kind of plug things back in as newtons. So you got to make sure that everything in the line has the same variable or like units with that thing. And that helps you relate these parts. So you could do this in a ton of different problems, but that's like just one example of this. But I've got, sorry, OneNote's being buggy. Give me a second. So here we have another problem where it helps to have this intuitive line form, but you also have to keep track of a couple different time scenarios. So there's like time 1, where there's this bullet going towards this block, then they collide, I'm calling that time 2, and then there's time 3, where they've slid across some surface and then they've stopped. So they're no longer moving at time 3. So the way I was thinking about this was I wanted to keep track of my signs and my work and my forces and solve for those little pieces, then relate them appropriately, where it's like, okay, I got to keep track of this sign. I want to keep track of this direction. For example, I know during what I'm labeling I and F at first, which is time 2 and time 3, that it was moving, it had some kinetic energy, and then ultimately it doesn't. So it has a negative change in that kinetic energy, so it's losing that kinetic energy, and that matches also the force of friction being in that negative direction. So you can relate all these pieces and their signs, but that's only possible when you take little equations and you solve for those little equations intuitively, then plug them back into like the sum of forces and all that stuff. So there was also like this force diagram here where I know that like in this object, it's not going up or down. So the sum of forces in the y is 0. So I'm able to equate these pieces. I do still think it's important to keep like gravity negative and then the normal force positive. So I tend to write that in, even though a lot of people will just be like force gravity is equal to force normal, and they'll just write them both out as positive values. I think it's better to keep those signs on there because it helps you keep track of this intuitively. And then you can solve for pieces where it's like, okay, I've got my initial and final where I'm plugging in those numbers. So I wouldn't rearrange this formula to solve for V1. I would get the pieces and plug them in this line format. And it's just so much easier to do that than to try and rearrange for like V1, because in that rearrangement, you might put a number in the wrong spot. But generally speaking, I found that people are able to relate numbers if you put it in a line format. Same sort of deal here. If you've got two parts and a whole, if you've got 222 and then 4, then you know what this other number is. Pretty easy if you leave it in that format. If you try and rearrange it, you might accidentally have thought that it was 222 plus 4 and that you're going to another bigger number. But having it in this line format is very, very useful in my opinion. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.